Okay, so now that we know how to deal with the molar mass, how are we going to use that molar mass in some calculations? Now, molar mass is a very useful number, all right? It is probably the most useful number in chemistry. So if we were to calculate the molar mass of carbon dioxide here, and again, remember how we would do that. It would be 16.0 times 2 plus 12.0 times 1. We would get 44.0 grams per mole. It's good to write that out and think it when you write it out. You want to say 44.0 grams per mole, all right? So what does that mean? That means that 1 mole, all right, of carbon dioxide has a mass of 44 grams per mole. So what would be the mass of 2 moles of carbon dioxide? Well, I don't think it's a stretch to think that if 1 mole, grams per mole, is 44 grams, then 2 moles would have to be, pause for thinking. Oh, and I'll assume Amy would put up her hand, and I'd say, okay, Amy, what is it going to be? And Amy would say, 88 grams or 88 grams. Excellent. And that's correct. 2 moles would be 88.0 grams. So if I want to figure out different masses, all I have to do is multiply the number of moles by the molar mass. So that brings us to some equations. So the mass of the substance we want to get is equal to the number of moles times the molar mass. Now we do have a proper equation for this, and it looks like this, where M is the mass in grams, N is the moles in moles, and molar mass is that molar mass that we calculated in grams per mole. I like to think of it in terms of the units. Another way I like to think of the equation is that if you want to get grams, you take your moles and you multiply it by your molar mass. All right? Notice it's the same thing, except I've just stuck the units into it. All right? And that makes it kind of easier because you can always go to your unit to figure out the equation. Because if I wanted to find the molar mass, I would divide off the moles, and another way of writing it would be molar mass is equal to grams divided by moles, and we can get this directly from our unit. So if we know the unit for the molar mass, grams per mole, then I know the formula, molar mass, grams per mole. And if we don't like rearranging equations, we can generate a triangle, and I know all the math people in the world are going to get excited about this. And if you've done this before, then you'll know the 1 on the top of the fraction goes there, then the rest of them go on the bottom, grams per mole. So if you know the unit, grams per mole, you can write it there, and then you can put the grams on the top and the moles on the bottom to figure out your equation. If we were to make a formula triangle out of this equation, all right, we would put the things that are multiplied together, N times molar mass, N times molar mass, and you'll notice we get the same thing, grams, molar mass, moles. I like this version because it has the units right into it, and this is another version. I'm going to use this. This is going to be our equation. Molar mass is equal to the grams divided by the moles, and I can get other versions of the equation using this triangle. So if I want to figure out the moles, I cover up moles. There I'm covering it up. That's equal to grams divided by molar mass. If I want to find grams, I'm covering it up. Molar mass times moles. Let's do some examples. All right. Oops. There it is right there. And again, my triangle, remember the unit for molar mass is grams per mole. So find the number of moles in 25 grams of aluminum hydroxide. I'm looking for moles. So let's write down our equation. Moles, cover that up, is grams divided by molar mass. All right. You'll see here we've got the grams. 25.0 grams. What do I need? I need the molar mass. Now, the molar mass comes from the chemical formula. So we need to be given the name in order to determine the molar mass. Aluminum hydroxide. So off to the side, aluminum. I need to know how to get my formulas. Hydroxide is OH. When you check your chart, 1 goes down here. Aluminum is 3, goes down there. So I need a molar mass of aluminum hydroxide. So what does this mean? Whenever you've got to find a molar mass, you need to go looking for the formula. So as soon as you need to find the molar mass in this equation, you need to go to the formula. Okay. So 1.0 times 3, 16.0 times 3. Remember, the 3 goes in. And aluminum, I need my periodic table. Aluminum is 27.0, 27.0, and that's just times 1. So now I'm getting my calculator. 3 plus 16 times 3 plus 27 equals, and that is 78.0 grams per mole. All right, now I know the molar mass. So I can put that in there, 78.0 grams per mole. Now I'm ready to find the moles. 25 divided by 78 equals, and that is 0.32, and this last digit would round to 1, and that is moles of substance. Remember, I've got 3 significant digits here, 3 significant digits here. I'm going to have 3 significant digits there, and that is the correct answer. All right? So we wanted to find moles. We found our equation, grams over molar mass. Once I needed the molar mass, I needed the formula for aluminum hydroxide to get that molar mass, and then I could calculate it. Let's do another one. So again, our triangle. Remember, it comes from the units. The units for molar mass are grams per mole. That's how you're going to get your triangle. Find the mass. I'm looking for the grams, G. This time, I multiply them together. They're beside each other, remember? Molar mass times moles. Molar mass times moles. Notice I'm given the number of moles, and I need the molar mass. I have to go to the formula. Sodium, Na. Bicarbonate, checking on the chart, HCO3, and you'll find 1 and 1. So that is done. 16 times 3. I know you can't see it there very well, but that's a 3. 12. And there's just 1, so I don't need to put times 1. 1. And there's just 1, so I don't need to put times 1. And Na, I need to check my periodic table. 23.0. 23.0. And now I need to calculate and add it up. 16 times 3 plus 12 plus 1 plus 23 equals, so sodium bicarbonate has a mass of 84.0 grams per mole. The reason I add the 0.0 is because these are all 0.0s, and that gives me 1, 2, 3 significant digits. This number also has 1, 2, 3 significant digits. So, molar mass, 84 grams per mole. Number of moles, 1.50 times 10 to the negative 1. Remember how we learned how to calculate the other day? It's going to be 84 in my calculator, 84 times. Then I put in 1.50. 1.50. And then remember, for scientific notation, EE or EXP, on my calculator, it's EXP negative 1 equals. And that gives me a number of 12.6. This is unit mole. So I'm looking for grams. The unit is grams, because the way I've built the equation, it shows you the unit. All right, excellent. So we found the mass. First, we determined what we were looking for, find the mass, and we got our equation. We multiplied them. We then needed a molar mass, which means we needed the formula to get the molar mass. Once we had the molar mass, we could multiply it by the number of moles. Excellent. Number 3, again, our triangle. Remember, molar mass has a unit of grams per mole. So molar mass, I always start down here, grams per mole. Excellent. 0.75 moles of an unknown gas has a mass of 5 grams. Find the molar mass. All right, this time we're looking for molar mass. So that's what I'm trying to find. Molar mass equals grams divided by moles. That's the unit of molar mass. That's how we know the formula, grams over moles. We've got grams, we've got moles, we've got everything we need. We now can calculate the molar mass. So this molar mass, notice we don't know what the substance is, so we don't use our arrow notation. We've given enough information, grams and moles, to find that molar mass. 5.0 grams, 0.75 moles, and I get my calculator out. 5 divided by 0.75 equals, and I have 6.7, because it's 6.666, there's 2 significant digits, grams per mole. All right? Okay? So that's the third way we can calculate it. One more, just to keep us on our toes. Again, triangle if you're using it. All right? Molar mass, grams per mole, and there's the per right there, that line there, grams per mole. How many moles are in 2.5 kilograms of ammonium nitrate fertilizer? So again, we're looking for moles. Moles. Moles, grams divided by molar mass, because on the bottom of our triangle we divide. Grams divided by molar mass. Notice we need molar mass here, so I need ammonium nitrate. NH4, ammonium. NO3, nitrate. 1, 1. There's our formula there. So we're ready to roll. 16. You're going to remember that oxygen is 16. We use it so often. Times 3. Notice I got 2 nitrogens, but I would do them separately. 14 times 1. 1.0 times 4. And again, another 14 times 1. Multiplying it. 16 times 3 plus 14 plus 4, because 1 times 4 is 4, plus 14 equals 80. 80 grams per mole. Always write that down. Always think grams per mole. That's how you get your equation. So let's put it in. Notice we have a kilo, 2.5. I think I've talked about kilo already. It stands for times 10 to the 3. So again, whenever you see kilo, you can put a times 10 to the 3. It means 1,000. Times 10 to the 3, and that turns the kilo into grams, because we must have it in grams. Molar mass, 80 grams per mole, and now we're ready to calculate. Again, using our proper scientific notation on the calculator, 2.5 EE or EXP, 3 divided by 80 equals and I get 31 point, and I get 31.25, right? 31.25, and that is moles, but there's only 2 digits there, so we're only going to keep these first 2 digits. 31 moles, all right? 31 moles. Okay, so now again, you've got a question sheet that deals with these types of calculations on Google Classroom, and you can now go ahead and work on those practice problems.